exponential and logarithmic equations now. We've talked about the basics, their properties. Now we have to talk about how to solve equations with them. All right? It's no surprise, an exponential equation is an equation containing a variable in the exponent. So for example, this one here, why is it? This one here is a exponential equation. And then this one here is an exponential equation. So notice in the first case, you've got one exponential, one power, and it equals a constant. Here you have that twice on either side of the equation. All right, and depending on the case, we use different properties to solve it. Okay, now let's talk about the one-to-one property. All right, and we're going to use it for exponential and then for logarithmic functions after that. All right. Right, different thing. So here, take a look at this. If you have b to the x equals to b to the y, so basically if the bases are the same, then in order for them to be equal to each other, the exponents have to be the same, right? So if you have 3 to the x equal to 3 to the 5, same base, you can set the exponents equal to each other. All right? Okay, so take a look here then. If we were to use the one-to-one property, then what I want is to make these bases the same. Okay? So here I have a 4 as a base and a 16 as a base. It's enough to make both of them 4s. You don't have to reduce it down to the most elemental base of 2. Okay? So if this is 4 to the x plus 2, I leave that untouched, right? But the 16, I can write that as 4 squared, right? Times x minus 3. Because if you have something to the exponent, then you multiply the exponents. Now that my bases are the same, all I have to do is set my exponents equal to each other. And it becomes a lovely algebraic equation. And I get that x is equal to 8.
What?
Okay? Okay.
Why can't we do it to the other side? Why can't we say that? Like, because 4 to some...
Here I have 2/3 and 9/4, right? Now, how do you go from 2/3 to 9/4? Well, not only do you square, but you also take the reciprocal, right? So what are we going to do here? So this is 2/3 to the power of x minus 5. And I have to write this in terms of 2/3. So I say 2/3 to the power of -2. All right? So again, once you do this, it has to be equivalent to what you started with. And then times 3x/4. Yes. So here we have x minus 5 is equal to -2 times 3x/4. So that's just -3/2. X minus 5 is equal to -3x/2. We can cross multiply. 2x minus 10 equals -3x. 5x equals 10. X equals 2. What's the domain for exponential functions?
All real numbers.
All real numbers. So, there's less and less need to check for solutions, like to see if it works. Okay, here, there is a problem. So basically you're saying 4 to the x is equal to a constant. You don't have that one-to-one option here, right? So what we're going to do now is, do you know? Tell me.
We get 4 to the power of log base 4.
Okay, you could do it that way. Yes, absolutely. So basically we're going to use a log because, look, if you have 3 times x is equal to 6, what do you do here to both sides? You divide. Why do you divide? Because this is being multiplied, and when you divide, division is the inverse of multiplication. So if here you have an exponential function, its inverse is a logarithm. So you could do 4 to the power of log, or we could take the log of both sides. So we have a base of 4, so we do log base 4, 4 to the x, equals log base 4, 13. Yes. Well, right, but eventually that's what this is going to turn into. You can. Yeah. Okay, but we have to know where things came from. Yeah. So now log base 4, 4 to the x, this is just x equal to log base 4 of 13. Now, if this is a no calculator section, this is how you leave it, right? Or you could put it in your calculator. Your calculators can just evaluate this. If you have a calculator, then it's 1.850. Okay? All right. Here we have a base of e. So log base e, remember, is ln. So I say ln of e of 2x plus 1 is 2x plus 1 equals ln of 8. It's super, super important here that you don't plug any numbers in, even if you have a calculator available, until the very end. So 2x is ln of 8 minus 1. X is ln of 8 minus 1 all over 2. Again, this is acceptable on a non-calculator section. With a calculator, it's 0.540. This should, for the most part, be a review from Algebra 2. Okay? Now, what if you have logarithmic equation? Same stuff applies. You still have the one-to-one property. So, if you have log base b of something equals log base b of something else, you just set the insides equal to each other. Okay? Now, let's take a look at this. So here I have 2 ln of x equals 8. First, I'm going to divide by 2. So ln of x equals 9. Okay, now what?
Raise them both,
right. Okay, so if this is a logarithm, what's the answer to a logarithm always? An exponent, right? What is the base here? What is the base? It's an e, right? So that means x is equal to the base to the exponent. X equals e to the 9. All right? I do want you guys to use this, this property. Now, sorry. Let me write this over here. Again, this is a logarithm. The inverse of it is an exponential. So could you also do this? E to the power of the left side equals e to the power of the right side. Do you end with the same thing? Of course you do. Why do I like this? Because it's quicker, and then it really makes you think about what all this logarithm business means. Okay, now let's take a look at this one. I'm going to subtract 7. Negative 3 log 10x is equal to 6. Divide by negative 3. So log 10x is equal to negative 2. Okay. This is a logarithm. Where in here is the exponent? The negative 2 is the exponent, right? Okay, now every exponent needs a base. Is that right? Where's the base here? It's 10. It's totally 10. So now, if this was a logarithm, base, exponent, what should it equal to? What is the answer? 10x, right? Right, so this, no, because it's an x there. There's a 10x. So this is why I'm saying, let's think of it in terms of what a logarithm is. A logarithm, the answer to a logarithm is an exponent. Well, every exponent needs a base. So base to the power of the exponent must always equal this number. Okay? So base to the power of the exponent must always equal this number 10x. All right. So now divide by 10, divide by 10. X is 10 to the negative 2 over 10. How much is that? 10 to the negative 3. But we don't like negative exponents. So 1 over 1,000. Okay? All right. Here, one more time. This is a logarithmic equation. Where is the exponent? 20. Every exponent needs a base. Where's the base? 5. So 5 to the power of 20 must equal what? The number that you haven't used yet, x to the 4. All right? You see how quickly we build that? And then it totally relies on our understanding of what logarithms and exponents are. Okay? Now look. We're going to solve this now. X to the power of 4 is 5 to the 20. What am I going to do? Take a 4, right. So raise this to the power of 1 over 4. Raise this to the power of 1 over 4. That's the same as a fourth root, right? So now I get x equals 5 to the power of how many? 5. And that's good enough. Don't, even with your calculator, don't plug that in. That's too big of a number. Yeah, usually once you get into the 4 digits, you don't even have to. Okay? Here, look, you have a logarithm with the same base. You're going to use the one-to-one property and just set those equal to each other. So x squared plus x equal to 20. And now it becomes a cute little problem. X squared plus x minus 20 equal to 0. X plus 5, x minus 4. So x equals negative 5, x equals 4. Do logarithms have a domain of all real numbers? No. No. It's 0 to infinity. Thank you. So your answers must check out. So you have to check your answers. All right, so let's just check this, the negative, x equals negative 5. Log base 5, negative 5 squared plus negative 5, is that equal to log base 5 of 20? Yes, so it works. And then you check the x equals 4, that works too, so both of these are answers. Basically, you want the left and the right to equal. You don't want any negative arguments for the logarithm. Okay, so negative answers are okay as long as once you put it into the log, right, it doesn't give you a negative argument inside the log. Okay, here, log, log, log. First, we're going to condense this. So log base 2 of 5 is equal to log base 2, 10 over x minus 4.
Why can't you just take out the log?
You can't. It's the one-to-one property, not the one-to-two property. You only can do that if you have one logarithm on either side of the equation.
So log 2 of 5 doesn't equal, but log 2, but 5, that means that 5 has to equal 10 minus x minus 4.
No, it equals 10 over x minus 4. Sure. But now, once you start solving it, you're going to get rid of the x in the denominator anyway because you cross multiply. You can only do it, I was just answering his question, the same question. You can only do it if you have one log on either side. Okay? That's the property. So now 5 equals 10 over x minus 4. Now you can cross multiply. So you get 5 times x minus 4 equals 10. 5x minus 20 equals 10. 5x equals 30. and x is 6.
Didn't you just do
Listen, past this point, it's algebra 1. Just get the value of x. You could do whatever you want. Just tell me. But you have to do it correctly. Like you have to use correct methods.
Yeah, I used the method. I just saw that that 5
Perfect. Great. Okay. Yeah, that's perfect. Yeah. Okay. Here you have one logarithm and then something else. So when you do this, you have to do base exponent. Where in here is the exponent? Right. Every exponent needs a base. What's the base? E is the base. All right. So e to the power, so the base to the power of the exponent equals what? What haven't we used yet? Y. Okay. So here, sorry, I don't have the directions. The directions here are solve for y. Okay. This is I took this out of a calculus problem. All right. And yeah, it's not that big of a deal, but this will be like step 1, and then you have to do all sorts of other stuff to it. So just know, okay, so this is the reason why I do it the way I do it, right? So again, every exponent needs a base. Base to the exponent equals the other number that we haven't used yet. Okay? Question. But on a test this year, you would have an equation like that, and you would be asked to solve for y. Right. Yeah, just that, exactly. Okay, all right, now here, these are the longer problems, okay? Now, here I have 3 to the power of this and 2 to the power of this. So in order for them to be the same on the left side and the right side, we're going to take the ln of both sides, okay? So if I rewrite this, what I have here is ln 3 to the power of 6 minus 3 equals ln 2 4 minus 4x. Okay, now this is a power property. What I do is I take this exponent and I move it down and it becomes a fraction. So 6x minus 3 times ln of 3. Most common mistake here is students forget to put the parentheses here, and then you can't do it properly. Equals 4 minus 4x times ln of 2. Now, I need to distribute. So on the left-hand side, I have 6x ln of 3 minus 3 ln of 3 equals 4 ln of 2 minus 4x ln of 2. What are we solving for? X. So now, I need everything with an x on the left side and everything without an x on the right side. So, 6x ln of 3 stays. This moves to the opposite side, so it becomes plus 4x ln of 2. Is that right? It takes so much space. Okay, is that better? So now 4 ln of 2 stays, but I need to take the negative 3 ln of 3 to the other side, so plus 3 ln of 3. We're almost there. Here, can I factor out an x?
Yeah.
So let's factor out an x. No, 1x, because I want to isolate x. Right? I want to isolate x. If I factor out a 2x, I still have to divide by 2 later. I want to factor out the x only because I want to solve for x. I'm isolating the x. So this will be 6 ln of 3 plus 4 ln of 2 equals 4 ln of 2, 3 ln of 3. Okay? Now,
Why did you choose natural logarithm? I think you could do any log, right?
it's the same because they're different bases. X equals, now I'm going to divide, so it'll be 4 ln of 2 plus 3 ln of 3 over 6 ln of 3 plus 4 ln of 2. But we're not done. No, you can't cross multiply. You can't, because it's one plus another. But what we're going to do is we're going to simplify this, because this is not simplified form. You have to condense. So x equals, all right, here, all of these become exponents, right? So it's going to be on top, ln of 2 to the 4 times 3 cubed. Does that make sense from the lesson before? Right? I have ln of 2 to the 4 plus ln of 3 cubed, but it combines as ln of a times b. On the bottom, I have ln of 3 to the 6 times 2 to the 4. So this is ln of 432 over ln of, how much is 3 to the 6 times 2 to the 4? Oh, what happened? 3 to the 6 times 2 to the 4? It's some number. I don't have it here, but you should simplify it. Okay? So there we have it. That's where we're at. Okay? Now, is it time consuming? Yes, but once you know how to do it from the moment you see it, then that at least, shaves off the time where you're thinking about how to do it. Okay, let's do the next one. Same exact deal. ln of, yeah, I just didn't have a calculator. 600 and, thank you. Okay? All right, here, again, we're going to take the ln of both sides. Okay? Bring down the factors. These are my favorite to solve. I could solve like a million of these. I love them. Okay, so now I distribute 2x ln of 6, 4 ln of 6, and I will give you more space on the test, equals negative x ln of 5 plus ln of 5. So do you see why here I only factored out an x, right? Because I'm going to have to divide by, I would have come up with the same answer later on. Okay, so now I'm going to bring all the x's to the same side. So 2x ln of 6 plus x ln of 5 equals ln of 5 minus 4 ln of 6. All right, and now here we have ln minus ln, so we're going to get like a fraction eventually. Okay, factor out an x. 2 ln of 6 plus ln of 5 is ln of 5 minus 4 ln of 6. I remember when I was first learning these, like back in high school, I used to think, oh my gosh, these were like such long problems. And then after seeing what I've seen, like in calculus and stuff, I'm like, oh my God, what a quick little problem this one is. So that's where you guys will be at, next year. All right, so x equals ln of 5 minus 4 ln of 6 over 2 ln 6 plus ln 5. Okay? Simplifying, this is ln of 5 over what number? 6 to the 4th. And then ln of 6 squared, 36 times 5, which is 180. Here it was negative x plus 1. Yeah.
Can you just do one big ln and two ln's?
No.
Why? Can you just do ln and then like a big fat? Like can't you see how you have an
No, because ln of a over ln of b.
But you can also say ln of a over b.
No. Okay, ln of a over ln of b is not the same as ln of a over b. These are not the same.
They have ln of a minus b.
Right. Yeah. Always think of them as roots. If you have root 5 over root 2, it's not the same as root 5 over 2. Yes.
Would you want to use 6 for it?
Yeah. So listen, so if it gets into the 4 or 5 digits, it's okay. You can leave it. All right. Okay. Oh my gosh, this next one. Oh my God, I love this next one. Like seriously. Right. Okay. Huh? Well, because this comes up. No, so you have ln of 5 minus ln of 6 to the 4. And then it'll be divided by. So you'll have ln of 5 minus ln of 6 to the 4. Okay, and then that'll be ln of 5 over 6 to the 4. Right. Okay, okay, so this one. Love, 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 love this one. Okay. Let's do some side work here. Okay. X squared plus 5x plus 6 equals 0. Why can we factor this like this? Right. And why does it? Because look at the form of this. You've got a constant. And then here you've got a variable. And how does this compare to that variable? It's the square of it, right? So I could have factored in the same form if this was a 4 and this was a 2, right? So basically you need constant, some variable, the square of the variable. So here's e to the x. What's e to the x squared? E to the 2x. So now, look here. Constant, some stuff with a variable, right? Some expression, and then that squared, right? Is that the same form as this? It is. So now, if I had x to the 4 plus 5x squared plus 6, how would I factor? I wouldn't do x and x. What would I do? X squared and x squared, because I take the square root of this. Same here. This is an exponential equation in quadratic form. So here I take the square root, e to the x, e to the x. And now I want two numbers, same thing, multiply to -2, add to -1. -2, +1, boom. Now, zero product property, two things being multiplied but equal to 0. I can solve each one of them. I could set each one of them equal to 0 and solve them. So e to the x minus 2 equal to 0. E to the x equals 2, right? And if I take an ln, then x equals ln of 2. And you know what? We leave it that way. Even if you have a calculator, you know, if it doesn't necessarily say to switch it to decimals, it's fine. Here, e to the x is equal to -1.
You can't do it.
Can't do it. ln, x is equal to ln of -1, problem. Can't do this, right? So that's the only solution. So back here, when we said e to the x is equal to -1, that should have already told us that that's not going to work. Because if you look at the graph for e to the x, does it ever go below 0? No. So right there, you should have already known that it's no solution. I'll ruin the element of surprise one more time. You have at least one of these on your test. Okay? Never, because the graph of an ln looks like this, asymptote here, and it looks like that, where that's equal to x equals 1. So the domain of the ln starts at 0 and goes up. Yes?
So one of A and B and one of C and D?
At least one of each. Yeah. I can't let you leave here without knowing that you can solve these. Okay. So this one goes very quickly. 40 e to the 0.6x is equal to 240. Basically, I just put this up because it's got a decimal exponent, but it's nothing special. It's actually rather boring. So then e to the 0.6x equals how much? 6. Now what do I do? ln. So 0.6x equals ln of 6. Whoa. X equals ln of 6 over 0.6, 2.986. Oh, the next one's a little bit more interesting. What do I do first here? Right, condense, right? We condense this. So it's ln of 7x plus 3 over x plus 1 equals ln of 2x. The one-to-one property, precisely. Okay, so go ahead and do it. I'm going to race you to it. I'll pause this for a minute. Negative 6x plus 1x should be negative 5x. So now I have x equals negative half and x equals 3. Are both of those solutions okay?
No, that doesn't make it up.
No, you can't have a negative.
You can have a negative in here, right? Because if you put the ln, if you put the x equals negative half in here, then you have ln of negative half, negative 1, which is no good. So we're going to throw that out. But the other one works.
So why can't it be 2x minus 3 and x plus 3?
Try it out, and if it works, I'll adjust this. Okay, try it out, and if it works, I'll adjust this. Let's do the next one. Okay. Here we're going to condense again. So I have log base 12. Let's do the factoring later.
Yeah, it works. It works.
Log base 12 of 12x times x minus 1 is equal to 12. Now, again, you've got a logarithm on one side, a constant on the other side. Again, the answer to a logarithm is always an exponent. So this is an exponent. But every exponent needs a base, which is 12. So 12 to the power of 12 is equal to what we haven't used yet, 12x, x minus 1. Okay, I'm solving for 12. Okay, I love this problem too. I'm solving for 12, right? I'm solving for x. So look, divide by 12, divide by 12. That's so cool, right? But still, look at what we end up with. This is 12 to the power of what? 11 equal to x squared minus x. So what this is x squared minus x minus 12 to the power of 11 equal to 0. Okay, we're not going to try to factor this one, so we're just going to leave it here. Okay? I just wanted you guys to do this stuff. Huh? 12 to the power of 11?
No, 12 to the power of 12.
Okay, so base exponent, so 12 to the power of 12 equals this number.
Why is it going to 12 to 11? The 12 to the power is 12 divided by 12 to the power of
So if you have 12 to the power of 12 over 12 to the power of 1, right? Same base, subtract exponents. Yeah, this one, it does, I mean, we're not going to factor this.